Hello everyone, my name is Avery Rutowski, and today I will discuss naming isomers using the CIP system to assign the R and S prefixes to chiral centers. So stereochemistry is the branch of chemistry that focuses on the spatial arrangement of atoms within molecules and the effects of this arrangement on their chemical behavior. Among the various types of isomers, chiral centers are particularly significant. R is meaning rectus, which is going right or clockwise, and then S is sinister, meaning left or going counterclockwise. So you can see that in the diagram shown on the right, and these labels are determined using the CIP priority rules. We need to make sure that these are chiral and not achiral molecules. The achiral ones will not have this configuration. So if we break this down step by step, our first step is to assign priorities to substituents. We will begin by identifying the 4 different substituents attached to the chiral center. Priorities are assigned based on atomic number. The higher the atomic number, the higher the priority. If 2 atoms attached to the chiral center are the same atomic number, then we will move outward from the chiral center, comparing the atomic numbers of the atoms directly attached to these substituents. Next, we are going to orient the molecules so that the substituent with the lowest priority, which is usually hydrogen, is directed away from the observer. This orientation ensures that we view the molecule along the axis of the chiral center, with the lowest priority group behind it. Our third step is to determine the sequence, so we will do this in which the 3 higher priority substituents are arranged around the chiral center. If the sequence from highest to lowest priority proceeds clockwise, the configuration is R. If it moves counterclockwise, the configuration is S. So if we consider 5 examples to illustrate this process, our first example shows a bromine atom, chlorine atom, and then CH3. So bromine has an atomic number of 35, chlorine has an atomic number of 17, and then the CH3 will have 9. So bromine will have our highest priority. It has the highest atomic number, so that will get priority number 1. Chlorine has priority number 2 with the next highest of 17, and then CH3 will have priority number 3. And then as you can see in this molecule already, the hydrogen is oriented away from us, our priority number 4. So in this one, we are moving clockwise, we will have an R configuration. In this next example, we have another bromine atom, we have chlorine, and then we have fluorine. The bromine, again, is 35, chlorine, 17, and then the fluorine is 9. So for this one, the bromine, again, will be the number 1 priority with the highest atomic number, the chlorine at number 2 with the second highest atomic number, and then fluorine at number 3 with the lowest. And then again, we orient the hydrogen away from us, and that has priority number 4. So this will be moving counterclockwise, having an S configuration. In this third example, we see 2 different molecules that are mirror images of each other. This is considered an enantiomer. And so the arrangement in this space does matter because it will change the configuration of these molecules. As you can see, the one on the left, the chlorine, is on the outside, and then on the right, it has flipped over. So on the one on the left, bromine has priority number 1 at 35, highest atomic number, and then chlorine at number 2 is 17, and then CH3 with 9 having priority number 3. The hydrogen oriented away from us, so still going counterclockwise on this one on the left would have an S configuration. And then when it is mirrored on the right side, then it changes the configuration to an R configuration. It is now going clockwise. So the arrangement in the space does matter when you are looking at these molecules. This next example, we have our chiral center where the hydrogen is coming out from. That hydrogen is already oriented away from us, giving it priority number 4. And then we have the hydroxide up at the top having the first priority. And then the 2 carbons connected to the chiral center are the same. So at this point, we will move out from the chiral center and look at the bonds on this one. So for the one on the right, the aldehyde, we have a double bond to the oxygen. While on the CH2OH side, we have a single bond to an oxygen. So if the atom is the same, like in this case, then the double bonds will have a higher priority than the single bonds. So therefore, this aldehyde group is assigned to number 2 priority, and then the CH2OH group on the left is assigned number 3 priority. And in this case, we are moving clockwise, so we have an R configuration. In this last example, we have bromine at the top, having the highest atomic number at 35. The hydrogen is oriented behind us with a priority number of 4. And then again, from the chiral center, it is connected to 2 carbons, and the carbon on the left is then connected to 3 additional carbons from the double bond and the other carbon on the bottom there. And then the one on the right is connected to 1 more carbon, but then it is connected to hydrogens after that. So the one on the left is going to have a higher atomic number overall. It is going to get priority number 2, and this will be moving counterclockwise, having an S configuration. And that is all that I have. So if you have any questions or comments, please feel free to leave them below, and I will be sure to answer them all. Thank you so much for watching.